Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about Bandit algorithm applications. This episode is based on a tech blog titled Enhancing Personalized CRM Communication with Contextual Bandit Strategies, written by the engineering team at Uber. You can find their link in this episode's description. Throughout this episode, we will explore this topic from both the business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Uber Technologies Incorporation is one of the world's largest technology platforms connecting riders, drivers, and delivery users across hundreds of cities. With a complex ecosystem of ride-hailing, food delivery, freight logistics, and more. Uber engages millions of users daily across multiple touchpoints. In this landscape, effective communication with users, whether it's through email or app notifications, is essential for customer engagement, maintaining their retentions and growth. Like many large technology companies, Uber uses customer relationship management systems to send targeted messages to users. This can include promotional offers, updates about features, reminders, or information about local services. The core challenge of the CRM system is personalization, sending the right message in the right format at the right time to the right individual. Traditional experimentation methods like A/B testing offer insights, but they are relatively slow and scale poorly, and they often fail to account for individual users' context. This can result in suboptimal experiences that underperform across diverse audiences. Why does this matter? Well, in the real world, user engagement is a direct driver of business outcomes. Higher email open rates, higher click-through rates, and in-app interactions translate to increased conversions, more frequent use of services, and ultimately long-term customer loyalty. In high-competitive digital markets, the personalization here is a strategic differentiator. Now that we've understood the business problem to solve, let's shift gear and dive into the technical side to see how Uber tackled this challenge. At the heart of this solution is an approach known as a contextual bandit. Before we unpack the machine learning architecture, it helps to understand what a contextual bandit is. Imagine a slot machine with many arms. In traditional experimentation, you might pull each arm a fixed number of times to see which one pays out best. However, that's slow and wastes opportunities to give users the best experience right away. Contextual bandits solve this problem by using context information, which are the information about the user and the situation, to adaptively choose the most promising option at each moment. That context could include a user's past behavior, their preferences, or characteristics of the message content itself. For Uber's CRM communications, the arms are the different combinations of components in an email or notification, like subject lines, pre-headers, visuals, wording, and more. Each variant represents a potential message that might resonate differently with different users. The context includes user-specific data like past interactions with Uber's communications and activity on Uber's app. One of the first steps Uber took was to represent email variants and user context in a way that machine learning models can use. The team used embeddings, which is numerical representations of text and preserve semantic meanings, to turn each component of an email into a vector. Specifically, they leveraged a generative AI embedding model that generates high-dimensional vectors for combinations of subject lines and preheaders. Then, they reduced the dimensionality of these embeddings using principal component analysis to make computations more manageable without losing important information. Once they had these embeddings, the system needed a way to match users with the most effective variant. The team experienced with two main models, LinUCB and XGBoost, with a post-processing algorithm called SquareCB. LinUCB is a simpler contextual bandit algorithm that assumes a linear relationship between user and content features, and then eventually reward, which is like an open or a click of the email. It's efficient and stateless, meaning it can be updated quickly with new data. However, it struggles with some nonlinear patterns in the data. That's where the XGBoost comes in. XGBoost is a gradient-boosted decision tree model known for capturing complex and nonlinear relationships. However, there is a trade-off. XGBoost does not natively handle uncertainty about its predictions in the way contextual bandits required. In other words, it's great at predicting which variant might perform well, but less suited for deciding when to explore less tested variants. To solve this problem, the team integrated SquareCB, which is an algorithm that adjusts model scores to balance exploration with exploitation. From an architectural standpoint, the system works as follows. Marketing teams define audiences and prepare communication templates. For each user in the audience, user context and content embeddings are fed into the prediction model. The model outputs predicted probabilities that a user will engage with each variant. Then, SquareCB adjusts these predictions to inject controlled exploration. Finally, the variant with the highest adjusted score is sent to the user. User responses, which includes opens, clicks, interactions, are then logged back into the data storage, retrained on future models, and used to improve future decisions. The team has a platform called Creative Optimization Platform. It orchestrates this pipeline and integrating multi-armed bandit logic, feature extraction, model scoring, post-processing, and logging all in one scalable and flexible way. Because embeddings and models generalize across campaigns and templates, this solution can also support scores of variants and many different types of communications without requiring separate models for each. Now, we've discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we explored how Uber tackled the challenge of personalizing CRM communications at scale through contextual bandit strategies. This work shows how data science can take a core business needs, which is to deliver relevant user communications, and build systems that adapt in near real time to maximize the impact. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.